Hi, I'm Susie.
And this is Gail. Have you ever stopped to consider how beautiful vegetables are? They have a remarkable variety of colors. What is it that makes them so colorful? Substances called pigments give them color. This activity explores the pigments carotenoids, chlorophyll, and anthocyanin. While challenging to pronounce and even more difficult to spell, carotenoids, chlorophyll, and the anthocyanins are an interesting component of fruits and vegetables. Carotenoids are bright yellow or orange and found in foods such as apricots, carrots, sweet potatoes, and dark green produce such as kale and broccoli. Dark greens don't look like they have carotenoids because the carotenoids are masked by chlorophyll. Chlorophyll is a green pigment that plants use for photosynthesis. The bright orange and yellow pigments of carotenoids hide beneath the chlorophyll. Think of trees that turn colors in the fall. All summer long their leaves are green. The chlorophyll is active. Then, as the season changes, the chlorophyll begins to dry up and reveal the oranges and yellows that were there all the time. It's the same with spinach and other dark green veggies. The carotenoids are masked by the chlorophyll. Anthocyanins are the third pigment in this activity. They are red, blue, and purple, so we see them in vegetables and fruits such as red cabbage, plums, blueberries, cranberries, and cherries. The way in which vegetables are cooked can alter pigments, as well as texture and flavor of vegetables. But since we eat with our eyes first, it's important to know how to prepare vegetables so they look appealing as well as have good texture and flavor. During this activity, youth experiment with pigments, specifically how heat, acid, and alkali affect the color, texture, and flavor of vegetables.
Before we talk more about carotenoids, chlorophyll, and anthocyanin, it will be helpful to understand the pH scale. The pH scale goes from 1 to 14. 7 at the middle of the scale is neutral. If something has a pH lower than 7, the solution is acidic, and over 7 it is basic, which is often called alkaline. Cooking ingredients such as fruit juices and vinegar are acidic. Baking soda is a common basic or alkaline ingredient. In the experiments, these ingredients are used to alter the pH of the cooking water.
Altering the pH of cooking water sometimes alters the appearance, texture, and flavor of vegetables. For instance, when red cabbage is cooked in acidic water, such as in a recipe with vinegar, the anthocyanin turns a bright color of reddish pink. With alkaline cooking water, the cabbage turns an unappetizing bluish green. Acids and bases also affect texture. Acids such as vinegar maintain a firm texture, while alkaline ingredients such as baking soda will soften the cooked product, often making it mushy. Some cooks may add a pinch of baking soda to the cooking water of broccoli. It gives a very vibrant and appetizing green color, but it destroys B vitamins and vitamin C. The texture also suffers, it becomes mushy.
The effects of pH on color are remarkable. The first red cabbage sample in this activity is prepared with tap water and has a slightly bluish-purple tint. That's because most city water supplies are slightly alkaline. That's good for our home water pipes so that mineral deposits don't build up in them, but not so good for cooking red cabbage. That's why some type of acid is included in most red cabbage recipes. An acid such as apple cider vinegar results in an appetizing color, good firm texture, and contributes to the flavor of the dish. The cabbage on the right has been cooked with added baking soda, making the cooking solution much more alkaline than tap water. This results in a greenish-blue color and a very mushy texture.
Learners will also experiment with foods that have carotenoids and chlorophyll. This activity will be an even better experience for you if you are comfortable with the pronunciation of the pigments. Carotenoids, chlorophyll, anthocyanin. That's it for this segment, but one last time. That's carotenoids, chlorophyll, anthocyanin.